Okay, so trapezoidal rule is exactly like the Riemann sum rectangular rule, but instead of using rectangles, we're going to use little trapezoids. Okay, so the first thing that we have to remember is the area of a trapezoid. Does anybody remember what the area of a trapezoid is? 1/2. Very good. It's like highlighted right there. Good job. Okay, so this little trapezoid is the one that you're going to kind of envision. Okay, so you have your width, which is the base length, okay, just like what we were doing with the rectangles, and then all you do is you just add the two heights of the two tops, okay, so the nice thing about this rule is you can see in this example that it kind of gives you a more exact estimate, okay? It is still giving you an estimate of the area underneath the curve, but it's just giving you a more precise estimate, okay? So if you have something that's like totally sloped down and doesn't have like flat edges, the trapezoidal rule is going to be more accurate, okay? All right, so let's just quickly find the area of this red shaded region. Okay, so we got 5 trapezoids in there. Let's start with the first little one. You guys see 1 is actually the shape of a triangle. So, in my opinion, the area of a triangle is a little bit easier than the area of a trapezoid, although you could do both. So, can we just say the area for number 1, that little triangle, be 1/2 times the base of 2 times the height of 4. If you wanted to do the trapezoid area, you would just do 4 plus 0 for the 2 heights, which still gives you 4. Okay, so now if we find the area of 2, we have 1/2 times, what's the base of that? 3, and then what are the 2 heights that you see? 4 plus 3, good. And then if we do number 3, that one has a really good estimate of that little shaded area. 1/2 times the width of 1, and our 2 heights, 3 plus 2, good. I'm going to kind of add on there. You could just write 5, absolutely. I'm just going to show my work just to show the 2 heights, but if you want to write 5, that's totally up to you. If we look at 4, I see a square. Anybody else see a square? Which you could still use the trapezoid area formula for, but I'm going to use 2 times 2 for that area. That's okay with you. And then for 5, that one is definitely a trapezoid. We got 1/2 times the base of 2 times the 2 heights, which are 2 plus 5. So, if we add all that together, we would get, let's see, we get 4 for the first one. Let's see, 7 times 3 is 21/2 for the second one. We would get 5/2 for the third one. We get 4 for the fourth one. And 7 times 2 is 14 divided by 2 is 7. And if you want to trust me on this, if you add it all up, you get 28 exactly. 28. Whoops, my bad on this one. I said thirds. You guys caught that? You wrote halves on your piece of paper. Alright, well that was super easy. Okay. Alright, so let's do another one. This time, they don't graph it for you. You have to graph it yourself and then come up with the little trapezoids. Okay, so example 2 says we're going to use 4 trapezoids. 4 trapezoids with equal widths, okay, of our curve. So let's start by drawing this x squared. Okay, what does that look like? Parabola. It's going to cross exactly through 1, 1, and 2, 4, right? If you just plug those x values in, right? I'm not even going to the left-hand side because I see that it's going to be bounded by the x-axis by x equals 0 and x equals 2. Okay, so we're basically looking between 0 and 2, and we're going to create 4 trapezoids. So if I have 4 trapezoids between 0 and 2, what are the widths? 0.5, good. Okay, so if you wanted to do the math on that, by the way, you could go 2 minus 0 divided by 4, which gives you 1/2. Okay, so here's my little trapezoid. So 1/2, that one's going to create a triangle. Okay, the second one is definitely a trapezoid. See how good of an approximation that is on a parabola? A rectangle would just not be as good. There's that one, and then the last one. That almost like fits it exactly. It's a little curved, so it's still an approximation. Okay, so if I'm going to find the area, I'm going to kind of do a little quicker step instead of finding the area of each trapezoid. Since all of the trapezoids start with 1/2 times the same width, which is 0.5, I'm going to start with that. So 1/2 times the width, which is all 1/2. And then all I'm going to do is add all the heights together for each of the 4 trapezoids. Okay, so on the first trapezoid, what are the 2 heights that you add together? Okay, definitely 0. And what's the height? If I plug in 1/2 into my x squared, what's 1/2 squared? 1/4. 1/4. So this is like trapezoid 1. Okay, now if I look at trapezoid 2, what are my 2 heights? So now I'm going between 1/2 and 1. So what's the height at 1/2? 1/4. And what's the height at 1? 1. Good. Okay, so now moving to the third one. This is the third one. What are my 2 heights on that one? 1 and 2? Are you sure it's exactly 2? Probably not. Yeah, how do we find exactly what it is? So if we plug in 3/2, which is the same as 1.5, right? 3/2 and square it. What's 3/2 squared? Good, 9/4. Okay, and then on our fourth one, what are the 2 heights? 9/4 plus, what's the height at 2? That one is exactly 4. Okay, so did anybody notice anything as we were going through this? The last one. The last one is the first. Okay, I kind of see what you're saying. Of each of the heights, you're looking at like these 2 are the same. Whoops, except for I wrote it wrong. Did anybody? I just can't write fractions right today. Let me rewrite that. Did you guys all write the right number? And these 2 are the same. These 2 are the same, right? So really what we could have done is I'm just going to multiply those in the front and go 0 plus 2 times 1/4 plus 2 times 1 plus 2 times 9/4 and then plus the last one. See the little trick? Yeah. And then just add that all together. And if you did, you can trust me, and it turns out to be 31/8. Exactly. Okay. So, I don't know about you, but I personally like shortcuts. That's like math in a nutshell, right? Okay, so they come up with this little formula for the trapezoidal rule, and it's basically exactly what we just noticed. Okay, so if you basically multiply all the middle heights by 2, that's the quick, easy way. Okay, do realize that this only works if all of the widths are the same. Okay, if the widths aren't the same, then you have to break it into each individual trapezoid. Okay. Okay, so let's use our quick little fast rule for number 3. This time we have a table of values, so we're using the table, which is kind of nice. We don't have to plug anything in. First thing I want to do is I want to figure out what our widths are. We have 4 trapezoids, And you can see my table goes from 10 to 50. So what's my widths? Okay, good. So maybe you did 50 minus 10 divided by 4 in your head and got 10. Or you just naturally did that in your head. So the area will be 1/2 times the widths of 10. Okay, and then we're going to do the first height, which is 1.8. And then we're going to add all of the other widths in the middle times 2. So 2 times 2, 2 times 2.5, 2 times 3.5, and then we get to 2.2. We're just going to do that one once because that's on the end, the outside. Okay, so that's the quick, easy way. You could type that straight in your calculator, and I think you would verify and get the same value that I got of 100. But you can type it in if you don't believe me. Good? Everybody agree? It's a big area, huh? So what do you guys think? Pretty tough? No. So I know this is the wrong thing there right here. So since this is just so simple, you gotta do all of it. Yeah. Oh, but it's my birthday, so.